Okay, welcome again to this soil section of the IPROMO course. Now we welcome Professor Michele Freppaz, and he will continue lecturing us about mountain soil and climate change. Michele, please.
Thanks a lot, Danilo, also for the great job you are doing for this IPROMO course. It's not the first time that you did such a great job as a chairman, so thanks a lot. So welcome everybody, good morning, good afternoon. It's a pleasure to have this short lecture with you concerning mountain soils and climate change. And Silvia introduced you to the characteristic and function of mountain soils, or soils in general, in particular of mountain soils. And in this lecture, I would like to focus on mountain soils and how they are affected by climate change, and also how soils can, in a way, contribute to mitigate, to adapt to climate change. So I think it's a very important issue. Soil, in particular, mountain soils have a specific role in this topic. Silvia already started with a video. Something didn't work. It was also my intention to start with a video. So here you can find the link on the video that I would like now try to share with you. If it doesn't work, I stop immediately, and then you will have time to have a look on it, and maybe we have time also to discuss in another time. Don't worry. So this is a video, 6 minutes, no more, that we produced in the framework of a big European Union project that we have concerning the specificities of mountain soils. So this is the link, and Danilo, if you don't mind, I try to start the video. If it doesn't work, please tell me, and I stop it immediately. Okay, Danilo?
Yes.
Okay. Okay, I try again. Let me see if something happened. Yeah.
No sound.
Okay.
Beautiful images, but no sound now.
It's something mysterious that we have to find a solution for WebEx. Sorry for that. So I stop it, okay, and I go on with the presentation. I'm able, and I will put the link on the chat. Okay. Sorry again for this, and I just move on. It's really strange, but something doesn't work with the video. Yeah.
Scusa, chiedono se si può lasciarli vedere dal link a loro, dargli il tempo di vederlo.
Ah, okay, this will be another option. It's 6 minutes. Okay, so I can copy and paste the link immediately from the chat. You can have a look on it, and then we can go on. Okay, it's a good solution. Thanks a lot. Allora, I do like this. And then so Danilo is on the chat, I think.
No.
Not yet.
Not now.
Not now. What about?
Okay.
Yeah, should be fine. So Danilo, I think 6 minutes. 7
okay.
Minutes. Okay.
So I guess we can stop the recording. Yeah.
Yeah. Sorry, but I think it could be
6 minutes silence.
I think so. Should take 6 minutes. So I hope you enjoyed. It was a video that we produced specifically on this topic. And so I think I can go on with the presentation, try to focus a little bit more about this issue. Okay, so I hope you enjoy the video, and I hope you realize that soils could store a huge amount of carbon. And Tommaso Chiti already told us about this potential of soils act as a sink of carbon. So soils have a potential to help mitigate climate change. But at the same time, they could work as a carbon source. And so they could, in a certain sense, exacerbate, increase, contribute to climate change. So it's quite difficult, to find a balance between these two functions of soils, as a carbon sink or as a carbon source. When we talk about carbon source, and also carbon sink. Of course, we need to know a little bit about the methodology, how we could assess the potentiality of a source to act as a carbon sink or as a carbon source. So one key word here that we have to keep in mind is the soil composition, how much carbon a soil could contain. And so here, if we consider on a volume basis, if we consider a normal soil, a soil in normal condition, so to say, this is the different components. So we can have more or less 25% of water in it, and Hans already told us about the importance of soils to store also water. Water is another key component of our earth, and also water could be stressed and affected by climate change. 25% of air, 45% of mineral, and 5% of organic matter, and carbon is a component of soil organic matter. So this is the percentage of much volume is occupied by organic matter. In order to have an idea of the stock of carbon stock, of course, we need other data. Other data that are not so simple to obtain, for example, the bulk density in kilogram per cubic meter, the depth of the horizon, the volume of rock fragments in the soil itself. In mountain, it's very common to have a huge amount of rock fragments in it. So it's something that we have to take into account. And also the importance of soil depth. Tommaso Chiti told us that most of the carbon is also contained in the subsoil, in the deeper part of the soil. While usually when we calculate the carbon stock, we just stopped in the 30, 40 centimeters in the upper part of the soil. So it's very complicated to obtain this number. And also it's very complicated to, in a certain sense, to make comparison between different papers, because it's very important to have the same methodology to assess the carbon stock. And here, just a few data that we obtained for mountain soils. Is a chapter where we are publishing hopefully in the next months concerning the soil carbon stock in the mountains. And as you can see, as a world average, we have more or less 161 tons per hectare. In the European Alps, we found some data, but very wide range from 60 to 280. It's something very wide range, because as I mentioned to you, it depends also on methodology, it depends on the environment. So but in any case, it's a huge amount of carbon which can be stocked into the soil. So this huge amount, without considering the pit soil, something that we didn't take into account in this number that you can see here, but if you consider pit soils, this amount could be larger, 300, 400, 500 tons per hectare. So it's something amazing considering potentiality of the soil to store carbon. Here also some number in the 30 centimeters of soils in tons per hectare of carbon stock in different environments, in different latitudes. As you can see here, also a wide range, these gray points here, but if you just try to have a line here, you can see how the carbon stock will be different according to the different climatic conditions, for example. So it's very, very important to keep in mind the variability of carbon stock, but in any case, the soil has a great potential to store carbon. What is also important is the quality of the organic matter. Okay, we have a total amount of carbon, but the organic matter can be constituted by different components. And for example, we can have fresh residues. Literally, also Tommaso showed a very nice video about the transformation of organic matter in the soil. So we have fresh litter, and this fresh litter, these fresh residues can be transformed through the action of organisms and other components. So we can have a particulate organic matter, we can have a formation of humus. We have also a formation of resistant organic matter. So the organic matter could be stored in the soil for quite a long time. So the turnover time of organic matter could be very different. But we have a very, very old unified substances in the soil. This is something amazing. I just found a very nice paper just published in 2020 and concerning the age distribution of global soil carbon. It was amazing. The mean age of soil carbon in the soil is close to 5,000 years. It's amazing. And of course, we could have also some soils where the organic carbon in it could have age close to 20,000 years. Of course, there are also other components which are younger, not so old in the soil, but as an average, close to 5,000 years. So it means that, okay, the carbon stock is really, really big, but also this carbon stock, this organic matter could be trapped, could be sealed in the soil for a long, long, long time. So it's something really amazing that we have to keep in mind. Also, it's very important to consider the living component of the organic matter. The soil could support a wide variety of organisms that live within it. And just to give you an idea of the potential of soils also in host life, soil is something which is alive, and it's not just dark material, dirty material without any life in it. No, it supports a wide range of organisms. And we know that this year the theme of the International Mountain Day is mountain biodiversity. So this slide is just dedicated to mountain biodiversity, in particular to mountain soil biodiversity. And this is just to give you an idea, considering our planet. For example, how many nematodes per square meter we can find in our soil. Of course, we can focus on mountain and also the huge amount of organisms that mountain soil could host. And here we have millions of nematodes per square meter, just imagine, that can be hosted into the soil. Just an idea of the great biodiversity that soil hosts. And especially mountain soils are an hotspot for biodiversity. And just Silvia told us about soil ecosystem services, soil function. And so here I just would like to stress this potential for soil as an habitat, as a hotspot for biodiversity. Is only one of the different functions of soil. For example, filtration and purification of water, nutrient cycle regulation, global and local climate regulation. This is the topic of this lecture concerning global and local climate regulation potentiality of soil. Before, there was also a nice question concerning how to give a value, economical value. This is really something that we have to remember. It's very, when we talk about the importance of soils, okay, we could talk about a lot about the biodiversity, the organism, but at the end, what is very useful is give number. How much does it cost? How much does it cost if we don't take care of soil? And there are different methods. Already Silvia told something about it, but I strongly believe that with economists, we have to work a lot in order to find a way to increase our ability to estimate also the value, the economical value of soil, because people are very, how to say, they take care about money. So if you just convert the beautiness and the importance of soil in something in euro or in other values, I think it's very important to let the people understand the real importance of soil. So how climate change could affect soils? So we could have some direct effects. For example, soil process changes in organic carbon transformation, nutrient cycling. If we have a change in moisture and temperature in the soil, the pedoclimate, we already talked about with Claudio Cassardo, Elisa Palazzi, Rodica, about changes in climate condition concerning the air temperature, amount of precipitation, of course, but these affect also the soil, the pedoclimate, temperature, water content in the soil are strongly affected by climate change. And something which is also very, very important as a direct effect is the potential increase in soil erosion rates, because we are experiencing higher frequency of high intensity, for example, rainfall events. Danilo already told about what we had in the last 48 hours here in Northwest Italy. I live in a small village in the mountain. It was amazing the amount of precipitation we had, close to 500 millimeters in 16 hours, something amazing. And so really the soil, the system could not support these high intensity rainfall events that also happened in the past. But according to climatologists and other people working on this subject, the frequency of these events is increasing. So it's something that we have to take care, that we have to take into consideration. Concerning the first part of this as a direct effect on changes in pedoclimate, I would like to stress you something which is very typical of mountain regions. And so the importance of the snow cover in conditioning the pedoclimate of soil. As you know, I'm a snow and soil scientist, both. So for me, soil and snow in mountain, and not only in mountain, are a continuous system. It's something that we have to study at the same time. If you want to understand in mountain, in seasonally snow-covered mountain, the behavior, the function, the morphology of soils, you have to remember that for a long time, this soil is covered by a snow cover. And also when I study the snow, I have to keep in mind that the snowpack could have different properties according to the different condition of soil. The main property that could affect the system is the insulation property of the snowpack. You know that if we have 60, 80 centimeters of snow, this blanket of snow is able to maintain the soil temperature constant during the winter time, independently from the air temperature. And so we have a temperature at the snow-soil interface, which is close to 0 degrees, even if the air temperature drops below -20, -25, doesn't matter. This is a system which maintains during winter time the temperature at the snow-soil interface close to 0. This is fundamental for the living components of the soil, for the roots, for the soil system. And so it's something that we have to remember. It's very simple but very powerful properties of the snowpack. Why studying these processes? When I start my lecture with snow ecology with my students, I say, okay, why someone spend all his life studying these processes? Because it's important. We have to keep in mind that 60% of the terrestrial surface experiences seasonal snow cover and seasonal snowfalls. I mean, it's something that a lot of people have to take care of these processes because it affects a wide surface of our planet. It's something really amazing. And as we already know very well, thanks to the colleagues that precede me, we know that the temperature has increased in the last 200 years in a very unexpected way. We know also the contribution of human activity to this warming rate, which is something really new in the history of our planet. But also what is important on my side, what I would like to add, also Hans told us about the changes in the cryosphere. The seasonal snow cover system is changing due to global warming. And so this is a very, very nice paper just published by this Italian colleague, Nicola, in 2020. And this is a wide, very nice survey of how the snow cover area has changed in the time period 2000-2018. And we found that, that more than 50% of the area show a rate of earlier melt greater than later onset. We have a very diffuse earlier spring snow melting. The snow melts before during springtime. And of course, these effects are more visible at elevation lower than 4,000 meters. At a very high elevation, most parameters concerning the snow show only significant negative changes. So we have an altitude belt where these changes are more visible. For example, in the Alps where I live, in the Italian Alps, the elevation belt most affected by these changes in the duration of the snow cover, in the snow cover area, are in between 1,000, 1,400, 1,600 meters above sea level. This is something an elevation belt where these processes are more affected. At very, very high elevation, this, the system is still cold, it's not so affected by these processes. And just to focus a little bit more on what I'm saying, this is a station here, a weather station in Switzerland, if I remember well, at 1,000 meters above sea level. And in green, you have the snow depth during the months of the year, the mean snow depth during the months of the year, in the time period 1989, 2008. And you, as you can see here, you have this value in comparison to what happened before in the time period 1909, 1988. As you can see here, you may expect that this elevation 45 centimeters on average during February. And now, in this time period, more recently, there is this very great reduction in the snow depth. Why? Hans already explained us. We have more rain instead of snow. We have an increase on the limit of the snowfall. And so we may expect during winter time, of course, precipitation in any case, but not as a snowfall, but as rain. So we have a very important shift, and with all the consequences on the hydrological cycle. Hans already told us very nicely what happened to the water mountain, no? And of course, I think that Daniele Bocchiola in the next 2 hours will explain also something concerning the effect of these changes in the distribution of the snowfall patterns according to the change in climate. And so what happened? Of course, we have less snow, we have a change in snow cover duration, we have a change in the snow depth, also in snow density. These rain or snow events also increase the density of the snow. We have more water, liquid water in it. So we have also change not only in the physical, but also probably in the quality of the snow. So we have to keep in mind these changes in snow characteristics, which are very, very important. And so here, sorry for this very full slide, but I try just to explain some key points. So we have a change in climate, and so we focus on a change in the cryosphere, in the snow characteristics. These changes could affect, for example, the soil temperature, but also the soil water content, so the pedoclimate. And here we can have different effects on the mechanics of soil, on the hydrology, on the organism, but also, for example, on the nutrient cycling, so on the carbon cycling or the nitrogen cycling. So we have a strong effect on the function, on the functionality, on the health of the soils. And how we could study these changes? For example, I spent here in Colorado, in the Rocky Mountains. They're working in a very important place where they started doing some snow manipulation in 1993. Using a snow fence is a way to change, thanks to the prevailing wind direction. It's a very nice place because thanks to this snow fence, we have always, or most of the time, the wind which just move from the left to the right, from the west to the east. And so the wind transport the snow. And through the action of the snow fence, we have a sector where we have a very deep snow cover, then we have a sector with moderate snow cover, and a sector with very shallow snow cover. So we can simulate, no? We can simulate an environment very rich in snow, an environment with moderate snow cover, and an environment with shallow snow cover, okay? So it's a way to manipulate naturally, naturally through the snow fence, the amount of snow, and we could study what happened to the soil. Now, I don't have time in details, but in 20 years, the soil here under the deep snow cover was completely different from the soils under the shallow snow cover. Okay, so just changing in the same area, in the same place, it's the same area, just changing the snow condition in 20 years, simulating deep or shallow snowpack, the two soils below, these two different environment, could change completely concerning the carbon stock, the nitrogen cycling, the vegetation also changed. So it was really amazing. Also here, another way to do this kind of snow manipulation is just shoveling. something that we can do, for example, where I work, because I have a lot of students, master students, so I have a lot of help. So another way to do snow manipulation is just to shovel, to maintain some plots without snow and compare what happened in these plots without snow in undisturbed place where we let the snow accumulate without any disturbance. And so we can make comparison, okay, what happened where we have snow, what we in the place where we remove artificially the snow thanks to the student, thanks to the shovels. And we have sharp changes, for example, in temperature. We have sharp changes in carbon and nitrogen form. Just to give you an idea, one of the only graph that I show you, I try to explain. This is one of the first snow manipulation we did in the Alps. We were at 1,400 meters. This elevation belt where we had such changes are more expressed, as I told you before. And so here we have in the black line, the earth temperature was a week in February. In February 2004 was a long time ago. Then the soil temperature at 10 centimeters depth. Here in the gray line where we remove the snow, as you can see here, the soil just froze, reached a temperature close to -4 degrees. And then this very, very nice line at 0, and where we had the snow undisturbed. So the snow acted as an insulator, maintained the temperature. So it's true what I told you, right? It's true. But what happened here is that was due to the lack of snow cover, changes, a freezing of the soils. And we have a sharp effect on different soil components due to the formation of ice. Just imagine these frozen soils was reaching water, so we have a formation of ice. And ice just increased the volume by 10%. Just imagine all this amount of ice into the soil could contribute to a physical destruction of soils. Macro and micro aggregates are destroyed with the exposure of previously inaccessible substrates to mineralization of faster rate. So change the physical and chemical properties of the soil. And just to give you an idea, I don't go in details of this graph, but we have a change, for example, in the production of inorganic nitrogen. We have a production of more nitrate in the soil. The nitrate could be leached by the soil. So a change, completely change the nutrient cycling of the system. If it is just after one season, one winter season without snow, just consider if this pattern continue for year by year by year. So we have a complete and sharp change in carbon and nitrogen cycling for something, for example, in this soil. Another point that I would like to stress you is the increased soil erosion rates, the loss of soil due to high intensity rainfall events. Okay, this is true, yes. I could also spend hours talking about these processes induced by rainfall, by high intensity rainfall, so the effect of liquid water on soil. But I would like to focus also on another point here in this lecture. High intensity rainfall could increase soil erosion, but also in mountain we have another specific phenomenon which could enhance soil erosion, connected also to the cryosphere, which is my domain of research. And so what happened? Climate change in mountains also led to warmer and wetter snowpack. Okay, less snow, more wet, more rain and snow events, but also this contributes to a higher frequency of snow avalanches, which run into snow-free areas. And especially, we have an increasing of occurrence of wet snow avalanches. Okay, the snowpack is getting warmer and denser and more rich in liquid water. So we have an increase in wet snow avalanches. Here I have another video. Danilo, I cannot play it. I'm quite sure that it doesn't work, but I will send you also the link about this video. We don't stop. Here is a very simple video just of a wet snow avalanche, that just to give you an idea what is a wet snow avalanche. It's an avalanche with a very high snow density, very rich in liquid water, low speed, but great erosive force. It's a very great potential to contribute to soil erosion. A particular kind of wet avalanche are the glide avalanches. The glide avalanches are avalanches made by snow which just flow, just move on the soil surface. So they really have a great erosive potential. Just here an image, here on the left, here of a glide avalanche, a kind of wet snow avalanche, which could really strongly contribute to soil erosion processes in mountains. What are the key factors to have this kind of snow movements? Very slow movements and then suddenly the release of the avalanche. We need little ruggedness of the soil. What is happening in the Alps due to the abandonment of agricultural activity? We have at high elevation, the grass is not still cut. We don't have animals grazing, and so we have this grass which can contribute, not yet grazed, not yet cut, to let the surface with little ruggedness. So it's very simple for the snow to slide on this surface. Of course, we need some slope. We need at least 15 degrees in order to have this phenomenon of glide avalanche. It's not so much. 15 degrees is just a gentle slope is enough. When temperature at the snow-soil interface close to zero, we realize that it's not a problem. In normal condition, if we have at least 60, 80 centimeters of snow, it can insulate the soil surface, so we have 0 degree. If we have 0 degree, we may expect some liquid water at the snow-soil interface, and this can contribute to the movement of the snow. In other conditions, for example, this is not possible. If we have permafrost, of course, if we have permafrost, even if we have the snow pack, the soil gets frozen, okay? So it's very hard to have this phenomenon. For example, here I have some data from the Sagarmatha National Park, where I spent very nice research activity a few weeks ago. And this is just the soil temperature. I don't want to waste time just describing it, but just imagine here during winter, you can have some snow here, there, not so much, but you may have in this area the temperature, because you could have permafrost, which can reach -10. So it's very hard to have this liquid water, 0 temperature for the snow in the soil. And then, of course, you need water, a huge amount of water. And usually you can have water just through snow melting. So you can have some very sunny days. You can have liquid water which infiltrate into the snow and reach the soil, creating this layer of liquid water in between the soil and the snow. And this can contribute to the movement of the snow itself. For example, we can have some rain or snow. So we can have not just only the contribution of the solar radiation in melting the snow, but also some rain and snow events which can contribute this amount of water, of liquid water in between the snow and the soil. And so at the end, the snowpack just moves slowly through the slope, and you can, at a certain point, it can break. You can break. So it's very common in the Alps, it's getting more and more common in mountain to have this sort of crevasse. So at a certain point, just the snowpack move and then crack. And now we have the opening of these cracks that we call as a glide cracks. And then at a certain point, okay, you can have like glide cracks, and occasionally we don't know exactly why and when. From these glide cracks, we can have the release of a glide avalanche. A glide avalanche, and it's really quite unpredictable to understand the passage, when you have these glide cracks and then there's no avalanche which is released. That is something that concerns the risk management in the area. I don't want to stress this point. What is really important on my point of view during this lecture is to stress the importance of this kind of phenomena, because they have a high erosive force. They have a potential to erode a huge amount of soil, contributing to the erosion in mountain areas due to rainfall. Of course, I really stress also this point. The high intensity of rainfall events are increasing the erosion processes in the mountain. Yes, it's true, but also the changes in the snow characteristics and also the increasing the frequency of wet avalanches is contributing to the increase of erosion processes. This is what you can see during summer. If you go on a slope during summer, you find such a kind of soil, you can say, okay, what happened here? What is the force which caused this kind of phenomenon? You have to remember what I told you, that during winter time we have snow, and the snow could move. So these processes, these phenomena are linked to the movement of snow, not to rainfall. Here also a PhD student of mine was Elisabetta. We work a lot on this topic. And during summer, you find such a kind of place, truncated soil profiles. And these erosion processes are due to snow avalanches, not to rainfall. And in certain point with students, we have a lot of fun because in some place we found these grass rolls. Here, a way to try to simulate what happened on a slope due to these processes. You have just to imagine that you have the soil, the grass cover on it, you have the snow, and the snow entrapped some grass at the bottom, then the snow move, and this grass just rotated, what to say, just move in this way and create these grass rolls. I really remember the first time that I brought my student to the field and say, okay, have a look here. Who did this? Who did? Snowpack did. The movement of the snow. So you are, of course, this just can start erosion processes, shallow landslides. It's something really important to keep in mind in managing mountain soil, specifically mountain soil. And of course, in the deposition area, in the runout area, you have a huge amount of soil which are transported from the upper part here due to these processes and just deposited, just left in the runout zone. You have a huge amount of soil here, tons and tons per hectare, and creating a hotspot here where which soils are different. You have a change in plant cover. These are unique places, also on a natural perspective, not only for risk for population, because it's an avalanche. I know it's something that we have also to manage according to the risk. But naturally, concerning the natural environment, this huge amount of soil transported from the upper elevation to the lower elevation transport nutrients, transport seeds of plants which grow at higher elevation, creating unique environment concerning the soil perspective, but also other subjects, other topics. And here just some, because we did a lot, just trying to estimate the material, it accumulate on the surface, is something really, really amazing. So I'm just going to the conclusion. I think I maintain my timetable. And so what are the take-home messages that I would like that you just bring home? So soils globally store more carbon than vegetation and atmosphere together. That's true. They store a huge amount of carbon. They act as a carbon sink. And in mountain is a real hotspot. Mountain soils are really able to keep all this carbon in it. As Tommaso Chitti told us, also in the deeper part of the soil profile, not only on the surface. There is a wide range of carbon stock, as I told you. It depends on the methodology, for example. It depends also on the different kind of soils we can find, especially in the mountain, according to the different forming factors that Silvia already explained us. So we have this very wide range, but in any case important, especially in peatlands. Climate change strongly affects the soil ecosystem services. Yes, it's true. And so changes in the climate could affect, for example, the pedoclimate, the climate in the soils, could affect also strongly the carbon and nitrogen cycling, for example. In mountain, changes in snow conditions strongly influence the soil temperature, the carbon and nitrogen cycling. I just focus on this aspect, considering how the cryosphere, the changes in the cryosphere could affect the soil, the mountain soil properties, and also concerning the cryosphere, wet avalanches, more frequent in a warmer climate, have a strong erosive force, could contribute for several tons per hectare, increasing the erosion due to rainfall. So what we started in the last year, also with the contribution of Silvia and other Swiss colleagues, we tried to calculate a way to have this correction factor, for example, for model for the estimation of the soil erosion, which take care only the rainfall and the intensity, the strength of the rainfall, also to also have this correction factor, which include also the erosion processes due, for example, to snow avalanches, in particular the glide avalanche. So I thanks a lot for your attention, and I think that with Silvia we are ready to try to answer to your question, and then I'm just would like to introduce also on my side, Danilo. Don't worry, sorry, I don't want to. It's your job, I know, but after our presentation, we have also a friend, which is Daniele Bocchiola, and so it's a pleasure also to say hello to him. So thanks again.
Okay, thank you, Michele, and don't worry, it's a pleasure to welcome Daniele, and I will welcome him better after the question and answer session.
Just a preliminary welcome.
I know. Okay, so there is already a question from Lupa, I guess for Silvia, but if you want to add some points, you are free to add them. So thank you for quite nice presentation. Just simple ask. How best can manure be managed to enhance soil fertility without causing any form of biodiversity loss due to excess nutrients concentration in some ecosystem like the grassland or rangelands under extensive system of livestock management? Also, how can the manure flow from the settlement camps of livestock on mountains be controlled from reaching out into the water stream and used for soil fertility and crop productivity?
Okay, Silvia, you go first. Maybe you have more time to reflect about it.
Okay, so yeah, I saw the question, and of course, every time you decide to take some action on soil, you have to think about the potential impacts of these actions. And in general, I guess you are speaking of extensive systems of livestock management. So even in extensive conditions, you need to make sure that the charge of and the intensity of grazing is not too much for your territory. So all the times you need to keep a cross-sectoral management with pastoralism and considering pastoralism, considering soils, considering water resources, and this is not easy. However, this is needed because if we want to keep soils in place and to keep soils healthy. And of course, all these actions, we saw the example of overgrazing before. Overgrazing in mountain areas can be a problem, and this has a lot of different impacts because it affects the vegetation and may select some species besides others because of competition. So affects the vegetation cover, but the vegetation cover in turn affects erosion processes because maybe it's not able to warrant adequate protection. And this may impact on the general biodiversity and the animals, and so can trigger a natural hazard. So the feedbacks are numerous and they need to be taken into account. So the best way would be to correctly organize grazing, considering the actual capacity of the territory. That's what I would recommend. And as for water filtration and groundwater recharge, again, leaching from soil can be a big problem. So again, the intensity of grazing is fundamental, but also the properties of soils, because of course we need to take into account the total depth of the soil, the structure, the permeability, and we can try to map the susceptibility of soils to infiltration and to pollution by leaching. So this can be a solution, maybe. What do you think, Michele? Audio, Michele?
I totally agree with you, Silvia. I think it's the proper answer.
Yeah, the key is sustainable soil management, but with an eye on cross-sectoral management. So consider soil, consider water, consider animals, grazing, and so on. So maybe you need a team of different experts to do that.
Okay, thank you very much. Are there additional questions or comments? because if not, we are perfectly in time to close the, let's say, soil section of this IPROMO day. Just to, technically speaking, I'm stopping now the recording of the